everyone, I'm Nitya, studying in Stephen Tester College of Engineering. Today I am here to discuss about concurrency control in databases, two-phase locking technique for concurrency control. Concurrency control in databases. Con- Concurrency control is a crucial database management system component. It manages simultaneously operations without them conflicting with each other. The primary aim is maintaining consistency, integrity, and isolation when multiple users or applications access the database simultaneously. In multiple user database environments, it's common for numerous users to want to access and modify databases simultaneously. This is what we call concurrent execution. Imagine a busy library where multiple librarians are updating book records simultaneously. This day, multiple librarians shouldn't try to update the same record simultaneously. Databases users shouldn't interface with each other operations. Why is concurrency control needed? To ensure database consistency. Without concurrency control, simultaneous translation transactions could interface with each other, leading to inconsistent database status. Proper concurrently control ensures the database remain consistent even after numerous concurrent transactions. Avoid conflicting updates. When two transactions attempt to update the same data simultaneously, one update might override the other without proper control. Concurrency control ensures that updates do not conflict and cause intended data loss. Prevent dirty readers. Without concurrency control, one transaction might read data, then another transaction is in middle of updating. This can lead to inaccurate or dirty reads, where the data doesn't reflect the final committed state. Enhance system efficiency. By managing concurrent access to database, concurrency control allows multiple transactions to be processed in parallel. This improves system throughput and makes optimal use of resources. Protection, transparency, or permissivity. For series of operations within transaction, it is crucial that all operations succeed or none do. Concurrency control ensures that transactions are atomic and treated as a single individual unit even when executed concurrently with each other. This is the two-phase locking technique of concurrency control diagram. Now, in two-phase locking technique, first phase is growing phase. In this phase, a transaction can quite acquire locks but cannot release any locks. The transaction continues to acquire locks on data items as needed. Locks can be of two types, shared locks and exclusive lock. A shared lock allows multiple transactions to read the data items but prevents any of them from writing to it. An exclusive lock allows a transaction to both read and write a data items exclusively. Once a transaction acquires a lock on a particular data, it might be continue acquiring but cannot release any until it reaches the next phase. Next, the shrinking phase. In the shrinking phase, a transaction can release locks but cannot acquire any new locks. A transaction starts releasing the locks it acquired during the growing phase. Once a lock is released, it cannot be reacquired. Once all the locks are released, the transaction is considered to be complete. Advantages of two-phase locking. Steerability. Two-phase locking ensures that the schedule of transactions is feasible, meaning that final result is the same as if the transaction were executed one after the other in same order. Deadlock prevention. Properly implemented two-phase locking helps prevent deadlocks. Occur when transactions are waiting for each other to release locks, creating a cycle of dependency. Consistency. The use of locks ensures that the transactions do not interfere with each other, maintaining the consistency of the database. Ease of implementation. Two-phase locking is relatively straightforward to implement and reason about. The protocol is well defined, making it easier for developers and database administrators to understand and manage. This simplicity contributes to the reliability of the technique. Drawbacks of two-phase locking. Blocking and reducing concurrency. One of the primary drawbacks of two-phase locking is the potential for blocking transaction. In growing phase, a transaction acquires locks and can be blocked if it cannot acquire a required lock. This blocking behavior can reduce overall concurrency as transaction may need to wait for other transactions to release locks. Lock cascading. In certain scenarios, a transaction may hold a lock on a resource for an extended period, preventing other transactions from accessing unrelated resources that are locked due to dependency. This is lock cascading and can impact concurrency. Looking overhead, acquiring and releasing locks increase some overhead in a highly concurrent environment with frequent lock consumption. This overhead can become significant and impact system performance. Fine-tuning the locking granularity and low management mechanism is essential to mitigate this overhead. Strict synchronization. Two-phase locking enforces a strict synchronization protocol where a transaction must acquire all its locks before releasing any. This rigidity can lead to suboptimal performance in scenarios where a more relaxed locking strategy might be appropriate. Conclusion. In conclusion, two-phase locking technique is a robust and widely adopted method for concurrency control in databases. Its structured approach to manage logs during the execution of the transactions help ensure consistency, isolation, and scalability of the database operation. The division of the transaction into growing and shrinking phases provide a systematic way to acquire and release logs, preventing issues such as database inconsistency and deadlocks. Thank you.